Hi everyone, my name is Arvind, and today I'm going to be talking about pointers, which is, I think, a really interesting concept in computer science because it can do some really interesting things with regards to object and array manipulation. And if you have a pointer bug, if you don't understand what pointers are, you can spend hours debugging. So this will save you a lot of time. So here I have a Python visualizer, which is basically going to run through this code step by step, and then it's going to show what's happening in the background on the right-hand side using a box and pointer plot. So we just run through this first line where we set x equal to 4. So what's happening here in the background is there's a set of 32 bits here that every variable in Python is assigned to a set of 32 bits. So this set of 32 bits is going to be equal to the value of 4. So in the next line, what I'm going to do is I'm going to set z equal to x. So what's going to happen here is a concept called copying the bits, which essentially what's happening is Python is going to allocate another 32 bits that's going to correspond to z, and then it's going to copy the bits that x is equal to into that 32-bit slot, and then z is going to be equal to that. So what's going to happen here is z is going to be equal to 4 because x is equal to 4, so z is now equal to 4. So we're copying these bits. And what's interesting is that even though I set x equal to 20 in the next line, z is unaffected because this is equal to a value of 4, has nothing to do with, it has no tie to x whatsoever. And this entire workflow and the way these variables work is going to be the same for all primitive types in Python. So your integers, floats, strings, and booleans, all going to be the same, all going to operate the same way. What's interesting though is when we start talking about objects, and so I'm going to instantiate a couple of objects here. I'm going to skip ahead in the code a little bit. And so what I've done here is I've created two different objects that have the same details on the inside, but they're completely different. And what's happening here is this set of 32 bits is not actually equal to this data here, because this data is obviously it's going to be more than 32 bits. So what Python does is it assigns a 32-bit address here that Rover is going to correspond to, and this address is going to point to a different area of memory that's going to be larger than 32 bits and can allow you to create an object that could have a lot of different attributes if you so choose. So the question I'm going to ask here is Rover the same as Rover 2? And the answer here is no, right? Because these are completely different instances, and even though they have the same details, they're just copies of each other, but they're not the same thing. So if I click next, we get the answer of false, which is true. What happens if I set Rover copy equal to Rover though? If we do the copying the bits concept from earlier, this address of 32 bits is going to be copied into another 32 bits here, and then we're going to set Rover copy equal to Rover, equal to this address, right? So that's exactly what happens in the next line. This pointer is pointing to this instance, and yeah, so the next question I'm going to ask is Rover the same as Rover copy, and they both point to the same instance. So the answer here is yes, they both correspond to the same instance. It's true. What gets really interesting is when we talk about attribute manipulation. So if I set Rover copy dot weight equal to 30, what's going to happen? So Rover copy, this address points to this instance. This is our weight here. This is going to change to 30, which is what happens when I hit next, right? So this is now 30. But the question is, what happened to Rover's weight? So is Rover's weight still 34, like we assigned it over here in line 10? Or is it going to be equal to 30? And the answer here is that it's actually equal to 30. So, I mean, if you follow the box and pointer like we did earlier, address points to this one, weight is 30, makes sense. This gets really interesting because if we start talking about potential bugs, let's say you assign, exactly what we did here, where we assigned Rover equal to an instance, then we assigned Rover copy to an address that corresponds to the same thing, and then we manipulated the weight using the second variable, and then you try to do stuff with the first variable without knowing that the second variable, that the instance was changed by a different variable, you can end up with some really interesting bugs that could take you a long time to fix. So always pay attention to where your pointers are pointing. And this can be for the next lesson, but this gets really interesting when we talk about arrays and different things pointing to each other. So I'll leave that for the next lesson, but I hope you learned something today.